Yeah, it's cool to be already in this early stage in my career part of something that can be meaningful to society and to science.
Ultra-strong, lightweight polymers are used in vital components in modern aircraft, cars and cables, for example. These polymers can be produced by upgrading waste plastics. However, current production processes have two major drawbacks. They require toxic additives and substantial amounts of energy, which results in large quantities of CO2. Eco-friendly alternatives are therefore needed. Insight project Hyper-Biopol is exploring solutions and found a nice trump card for this. Water.
There is a small temperature window in which you can use water by shaping the polyamides, which leads to a processing of polyamides below 100 degrees Celsius. So that's unique in our processing technology. Since the water is the byproduct in the reaction mixture, it can also decompose your polymer if you are not careful. Basically, you shield the material. After processing, you again remove your shielding agent to re-establish. So we call it reversible shielding approach.
It has a lot of potential. It's not a limited resource. It would allow for easier recycling, and at the same time the properties of the material improve. And a longer lifetime is of course good for the environment because you can use the material for a longer time, but also good for a customer using the material, also because the lifetime is longer.
Hydrogen bonds in these polymers influence the mechanical strength of the material produced. Hyper-Biopol researchers develop theoretical models to understand how water uptake influences the formation of such bonds and therefore the polymer's strength. This knowledge is used to design and produce new bio-based hydrophobic polyamides in carefully controlled processes in the presence of water and other sustainable additives.
We develop theoretical models in two ways. On one hand, we solve them analytically, and on the other hand, we use thousands of equations that can be solved by the computer. So theory guides experimentation, experimentation also guides theory, and knowing about the applications makes sure that we are all going in the right direction.
I find this project also has a huge impact on the industry. It's not like you do something in the lab and you publish it, leave it. But here you can do science, you can publish it, you can earn a patent, and it will have an impact over the industry. With the same existing polyamides, you are just enhancing its properties, so it will have direct influence over the current tire making industries. Yes, it's a groundbreaking technology in terms of polyamide processing. Yeah.
And I can imagine that this specific knowledge can also be used in other projects. Something I imagine is, for instance, that you create a system where water can condense out of the air to help with the water shortage problems. Or, for instance, also this application of using it to minimize water absorption in materials to extend lifetimes of materials in general.
The results so far are highly promising, and if the candidate polymers can be successfully upscaled and valorized, this revolutionary research could drastically reduce the environmental footprint of polymer production.
Your dream is always to have your product on the market, used by people.